Okay, this is the next section, 3-4. Again, this is pretty much a review of Algebra 2, if you think about it. Hopefully you see some of these problems and you are sitting there like, oh, we did that last year. Yeah, we did. Okay, so hopefully there's a comfort level there. What you can see here are the different properties of logarithms. You have your product property, where if you are multiplying in the log, you split them up into two separate logs and you add them together. Quotient, if you're dividing, that means you separate them into individual logs and you subtract them. If you have an exponent in your log, you move it out to the front. Okay? And the equality, which basically means if you have two logs set equal to each other and the bases are the same, then that means whatever you're taking the log of, those terms are also the same. And you can see examples right there. It's pretty straightforward. So if we're assuming that x and y are positive, they want you to use the properties of logarithms to write log 8xy to the fourth as a sum of logs or multiples of logs. I hate saying logarithms, like logarithms. No, it's log. Log, log, log. All right? Now, we have a multiplication here. Now, don't be fooled by that 4, okay? That 4 exponent only goes to the y, all right? So we're not going to put the 4 in front right away. We will, just not right away. So I have 3 terms here. So I'm going to write 3 logs. And I'm going to add them together because they are being multiplied together. So when you multiply, add. Now log 8's good, log x is good. Now we're going to look at this exponent of 4. And we're only going to move it out in front of that log. Okay? So that last log is the only special one. Okay? Now there's nothing else to do. You have singleton terms there. 8, x, and y are all good. There's your answer. Okay? It's very simple. Now if you're expanding a quotient, okay? Now, by the way, it says ln there. The rules for ln are the same as the rules for log. So there's no, different rule or anything like that. So I've got a division. So what do we do when we have a division? We subtract. So I have ln x squared of square root x squared minus... I can't talk. Wait. Hang on. Okay. Little Diet Coke there. So ln of the square root of x squared plus 5 minus ln x. Now the ln x is fine. There's nothing you can do with that. There's no properties you could use or anything like that. But the first one, oh, there's all kinds of stuff. So I've got ln. Now square root means what, everybody? I know you're all saying, it's the 1/2 power. Exactly. Okay? So what happens here? We have a power. We have an exponent. Okay, so we're going to move that out front. So I have 1/2 ln x squared plus 5 minus ln x. Now, here's the issue. Okay, if you look at, I'm going to use another color. Look at this. Oh, big time. That's big time teacher move right there. Okay, you cannot expand that because it's an addition inside. If this was 5x squared, then yes, you could pull it apart and do the adding and all that. But x squared plus 5 in the log stays right where it is. There's nothing to do with it. You're done with it. So this is your final answer. Okay? And like I said, we've done this before. Now, they want you to go the other way. Now they're going to give us the big long log expression, and they want us to condense it down into 1. So we're just going in reverse. Okay? So we have to take this whole thing and condense it down. Okay? So we have a subtraction. Subtraction means we divide. So I have ln x to the 5th divided by, whoops, sorry, screwed up. So ln x to the 5th divided by, now, see this 2? This 2 in front means that I'm going to have xy to the 2nd power. Okay? So we have to put it back where it was. Now, to simplify this even further, okay, and actually we can do a little bit more with this one. I'll go back to this one in a second. Inside this parenthesis, I've got x to the fifth. Now, what's xy squared? Well, you take the x and the y and you square it. So we're just simplifying as much as possible here. X to the fifth over x squared. Well, what do you do with the exponents when you divide? You subtract. So 5 minus 2 is 3. So I have x to the third over y to the second. And that's my final answer. So instead of 2 logs, we have now condensed that into 1 log. All right. Let me take you back to the first one. We've simplified that we use the properties to their maximum ability. We cannot do any more properties. However, we can simplify log 8. And you're sitting there going, well, how can you do that? I mean, it's log 8. There's no properties to use. What if I told you that the log of 8 is the same as the log of 2 to the third power? That's a printer in the background, by the way. Okay? So I can change 8 to 2 to the third power. Now, what does that mean? That means I have an exponent. I have a property to use. So now that 3 is going to go out front. Now my final answer would be 3 log 2 plus log x plus log y. So, in the scenario where you are doing the properties, if you have a number inside the log that you can break down further, so 8 can break down to 2 to the third, you do it. I had to pause. Senora Chavez came in and picked up some stuff off the printer. I'm in the math office. Okay, so you get the idea. Reduce everything down as much as you humanly can. Okay? That's why here we simplified what was inside the parentheses. Okay, change of base. Now, if you remember me telling you, Isaac, this is for you, you couldn't put in log base 4 in your calculator. The only log you could put in your calculator is the common log, log base 10. Well, change of base changes that. Okay? All right? Change of base formula basically means this. Okay? So, the log base b of x. Okay? I'm not really worried about this. This is the big one. Okay? Change of base means we change the base. So this starts out as log base b of x. Well, what that means is that we can change this log to 2 separate logs, both base 10. Remember, no subscript means 10 is the base. And we do the log of x and then the log of b. And then the same thing works for ln too. Okay? So if this was a natural log, the same rule applies. So if we come over here, okay, if they want you to figure out what that is, you can now put it in your calculator. So what you would do is you would just do log 16 over log 3. Now, the one thing you have to understand when you put this in your calculator, okay, you've got to finish the parentheses around 16, okay? Because if you don't, the calculator is going to read it funky, and you're not going to get the right answer. So make sure that the parentheses are closed around both those numbers. Same thing here. And then you would figure out what that is. I don't have a calculator in front of me, I apologize. But I'm sure you can all punch buttons in a calculator. I know you're all very good at that. So log base 10 divided by log of 10 divided by log of 6, and whatever you get. Log 2 divided by log 1/2. Okay? Now this one's interesting. This last one's interesting. Before you go plugging that in your calculator, that last one, part C, take a look. How else could I write 1/2? 1/2 I can write as 2 to the negative 1 power. But that negative 1 exponent, where does that go? And you're all screaming, it goes in front of the log! It goes in front of the log! That is correct. So I have log 2 over negative log 2. Well, what happens? Log 2 divided by log 2 is, well, 1. And the negative on the bottom makes this -1. So that's your answer. Now, I'm sure you can plug that in your calculator, real fancy, dancy, and hey, it's -1. Oh, I did it in the calculator. Well, that's the math behind it. Okay? So change of base formula is real easy with the calculator. Okay, now this is important. Okay? Using the change of base formula, we can rewrite any log function, g of x equals log base b of x, as a quotient of the natural logs. Notice how ln x, ln b, so it's just like change of base formula, exact same. But what they do here, look what they did from here to here. They took out the ln b, so it's 1 over ln b times ln x. Okay? So they took the fraction and they sort of split it up into two parts. Okay? Now, what does that mean? That means that you have a vertical stretch. Why am I writing it up here? I have an entire slide. It's a vertical stretch or shrink, depending on what the number is, by a factor. Now, whatever number's in front, right? Well, the number in front here is 1 over ln b. So whatever that fraction is, that's the stretch or shrink. Okay? All right. So what happens here, and it explains it right here. Therefore, every log function is a constant multiple of the natural log function, f of x equals ln x. If the base is bigger than 1, okay, so if this b right here is bigger than 1, then you have a vertical stretch or shrink by the factor of that. Now, it says if b is between 0 and 1, so if b was a half, a third, 2/3, just a couple examples, then you're going to do the same thing, but the difference here is not only are you going to get the vertical stretch, you are also going to get a reflection across the x-axis. Okay? So keep that in mind. Now, we're going to describe how to transform these. Well, what do we have? We're going to change the base, so g of x, so this is part A, g of x is ln x over ln 5. Okay? Now we pull it out, so 1 over ln 5 times ln x. Okay? Now, what do we have? It says describe how to transform the graph of this into this graph. Well, we have a vertical b, here's b, b is bigger than 1, so we have a vertical stretch by a factor of 1 over ln 5. Okay? So that's what happens. You stretch it by a factor of 1 over ln 5. Now, part B, okay, we do our change of base again, except this time it's log x, ln, dummy, ln x over ln 1/4. Now, remember, we can rewrite 1/4 as 4 to the -1 power. But, again, you have an exponent. Property says it goes out front. So what I have is I have ln x over negative ln 4. Pull out your ln 4 or your negative ln 4. So you have -1 over ln 4 times ln x. Okay, so you have a vertical, well, first you have a reflection. Okay, you have a reflection because of that negative sign right there. So reflect across the x-axis, and you have a vertical, you have a vertical, well, it's a vertical shrink. They're both vertical shrinks. Sorry. Whoopsie. I should know that. You know, being the math teacher and all. It's a vertical shrink by a factor of 1 over ln 5. The reason why it's a shrink, guys, is because of the fraction. Okay, 1 over ln 5 is 1 over some number. It's a fraction. Okay, if the number in front is a fraction less than 1, you're going to get a shrink. That's why. My bad. So you're going to get a vertical shrink by a factor, that's the printer again, by a factor of 1 over ln 4. Notice I didn't put the negative there because the reflection took care of the negative. Now we just focus on the fraction. Okay, so that is 3.4, and we will work on that very soon, probably Monday. Have a good weekend, guys.